Okay guys, I said earlier in the week that I'm going to try to explain some of the energy systems to you. From the programming the last 3 or 4 weeks, seems like people have had some questions, maybe not understanding what it is I'm talking about. So I'm going to try to briefly explain them to you, some graphs up here. So let's get into it. There are really 3 energy systems for the human body, and basically how we express energy and how we use energy. That's the phosphagen energy system, the glycolytic energy system, and the aerobic energy system or oxidative energy system. There's some big differences in between the 3 of them. All right. Start off with some examples to kind of wrap your mind around as we're going through. It's going to be the same mode domain of running, but an example of the phosphagen energy system with a run would be like a 40-yard sprint. Okay. An example of the glycolytic energy system would be like a 400-meter run. An example of the oxidative or the aerobic energy system will be like a mile run or a 5K run or a marathon. Okay, that's an example of each one of those things. So let's explain them a little bit so you understand them. The phosphagen energy system, it has a very high power output, but you can sustain that high power output for a very short time duration, so it has a very low capacity. All right, so if you're looking at the phosphagen energy system on this graph, that's this red line. You notice I can get all the way up to 100% max effort, 100% of total power, or percentage of total energy expenditure. But you'll notice a very, very deep decrease in the amount of time I can do that for. So we're looking at about 1 second, somewhere around like 10 seconds tops for the phosphagen energy system. And then from there, the glycolytic will take over. Another example of that phosphagen energy system would be like Olympic weightlifting, right? Power cleans for 1 to maybe 5 reps, like probably with 1 to 3 reps. Okay, and you'll notice that if you try to do a 1 rep max on a high power thing like a power clean or a snatch, you're not able to repeat that 1 rep max again immediately. It's because this phosphagen energy system actually needs more time to recover. Okay. The next energy system, if you look at the graph here, is this blue line. That's the glycolytic energy system. Glycolytic energy system starts to take over at about 30 seconds. 30 seconds to about 2 minutes. All right, with the peak of it coming somewhere in between there, like about a minute or so, where you're really reaching that highest potential power output of the glycolytic energy system, which is somewhere around 60 to 75%, probably like 70% of total power that you're able to produce, and that's able to be produced by the glycolytic energy system. Okay, so high power output, low capacity still low, not super low, not 10 seconds, but still low at about 2 minutes for time capacity. The third energy system is the oxidative or aerobic energy system. And when we're looking at the aerobic energy system, we're thinking of that longer run to longer time duration. The benefits of this is that you can sustain that effort for a long period of time, but the power output's very, very low. So if you're talking about a mile or a 5K run, the power output of that's going to be super low. And we're going maybe topping at like 40% power output, maybe. Probably closer to like 25 to 30% power output. But you notice here, that line goes on almost indefinitely, right? So you can run a 100-mile race using the aerobic energy system, something like that, okay? So low power output, very long time duration, very high capacity for holding on to that energy system. Hopefully that explains it a little bit more. It doesn't make it more confusing. The idea is for you to learn a little bit more about why we're doing what we're doing, okay? Cool.